Welcome back from the break. Um, we are starting another topic, which is just simple about partial. It's about partial fractions. So that's what we are going to do today. But this partial fraction which we are going to look at, they are studied both in this session or in algebra, and also you find them when you go to integration, or there's a kind of integration where you need to partial fraction so that you can continue. So, but for us, we are going to begin with those ones in algebra, which are just like this. And we know that when we talk of partial is something which is just a part of a fraction. That means when they talk of partial fraction is part of a fraction. And also, what we know that what a fraction means. A fraction means the number which divides by another. So as assuming here I have 2 and I divide it by 5. This one is a fraction, but it depends on which type of fractions are you considering. So we are going also to consider those types of fractions. And the types of fraction which we are going to consider, one of them is the linear fractions. These linear fractions which you are going to deal with, this one is just, they are fractions which are just on the straight line. Yes, they are fractions which are on the straight line. For example, if linear means a line like this is a line. So examples of linear fraction examples include like, for instance, if you take 2 out of x plus 1, this is a linear fraction. Also, when it is 2, maybe 2x plus 2 out of 3x plus 4. So these are kinds of linear fraction which we are talking of. And for this case, when you are considering linear fraction, they need you to first divide or use wrong division, because when you see this degree here, because here it is power 1, this is power 1. So if the powers are the same, that means you need to first divide. So this one, they are assumed to be improper. So that kind of all those fractions, you're going to deal with them. So also, under the linear fraction, is also quadratic. We say the quadratic, they begin with x squared, quadratic, or it can be quartic, we say it begins with x power 4, this is x squared, or it can be cubic, of which the cubic we say it is x power 3. So, and many others which we shall find. So, having seen that one, we shall see also we have other kinds of fraction which we deal with. The first one, also the kind of fraction which we deal is the proper, from the other ordinary fraction which we know that the proper fractions. For these ones that the numerator is less than the denominator in the quantity, or you may find that the numerator is 2 out of x plus 1, or 2 out of x squared plus 2, like that, or it may be x squared plus 3, then divide by x power 4 plus 4x plus 2. So for this one, what we call is a proper fraction, because the degree of the numerator is less than the degree of the denominator. So that one gives us a name as a proper fraction. So also there is improper. Improper also from the ordinary fractions, improper fraction. This one, it shows that all the things, or what is the numerator is bigger in degree than the denominator. For instance, if we take x squared plus 2 plus 2x plus 4 out of x plus 5. This is an improper. Also, when you are considering partial fraction, also this one is said to be improper if this one is x squared plus 2x minus 4 out of x squared plus 3x plus 5. Also, this one is said to be improper since they have the same degree of in only partial fraction. That's why I consider it as improper. So after getting that one, after understanding all of this, what also have to know about is that when you're considering partial fraction, also we consider the nature of the denominator, which is there, and the numerator. So when we are considering the denominator, we said we have the linear, we have quadratic. Also, there's another kind of fraction which we shall be looking at, which is repeated fraction to add on linear and quadratic, cubic and others. There is repeated fractions. Now for the repeated fraction, we find that the equation is 5x plus 4 out of x plus 2, the whole thing squared, then plus maybe times x plus 3. So this thing is repeated. Is a way how we do it when we are dealing with something like that. So even though it is the x plus 2 squared, comma x plus 4 cubed, and so on. It is the way how we shall do it as we continue. Also, what you have to know that when you are getting partial fractions, or let us first go on the quadratic fractions. So when solving partial fractions, when you are considering quadratic functions, also what you must first know is the equation which you are considering having factors or does not have. If it has factors, you must first make sure that you try to reduce it to its lowest factors by getting the values of x, assuming it is x squared minus 3x plus 2. So if you find that this equation has factors, so you first factorize it into its form, then continue. So if you find that it has no factors, so take it as the way it is. Take it as the way it is. And we have to know that when you are dealing with quadratic equations, when the equations have no factors, what we equate to with it, or what we write under its numerator is just ax, assuming it is the first ax plus b, then divide by that quadratic, assuming it is x squared minus 5x plus 7. So assuming it is like that, that's how we write it. But when it is linear, we say linear. So what we do, we say it is a, assuming if it was like this, then in times x plus 4. When it has to be like this, we should say that this one is equivalent. When we are dealing with partial fraction, we don't say equals, we say equivalent. So equivalent is represented by three lines like this. So for this case, it will be a out of x plus 1 plus b out of x plus 4. But when you meet anything which is partial, which cannot be split in its simplest form, what you do, you apply the component of x in it. So having got that one, so we can continue with the discussion by looking at the examples. So examples, we're going to take everything at once. So it is just on your side to determine whether this one is equal to what, this one is linear or repeated. So everything we are doing it at once. So the question is saying that express the following two partial fractions. Express the following into partial fractions. So these are the things which are expressed into partial fraction. The first one is 1 minus x, or it is x minus 1 out of all over x plus 1 times x minus 2. So number 2 is 2x plus 1 out of 2x plus 1 out of x plus 1 times x squared plus 7x plus 2. So this is what we have. Also the other third one is 1 out of x cubed minus 9x minus 9x. So those are the three equations or the fractions which they have given us, and they want us to solve them and express them in terms of partial fractions. So now what we do, we are beginning with the first question solution. Number 1. You're saying x minus 1 out of x plus 1 times x minus 2. So we say this one, we write it as equivalent. Equivalent to, we said when it is linear, we just say it is a out of this one, x plus 1. Then when it is like this, or when it is multiplication, we just add. We say plus b. Also when this one is linear, we just say b. From A you go to B, you go to C, D, like that. So that's how we move when we are dealing with partial fraction. This is x minus 2. So after doing this, what we do is say, hey, the whole of this thing is equated to this one, but what we do first get the LCM and multiply it with this one. So by doing this, okay, it's like this. After getting the LCM to x minus 1 out of x plus 1, x minus 2. So we get LCM the other side, which is x plus 1 times x minus 2. So divided by this one, divided by this, it remains with only this times that, which is n into x minus 2. So plus this one divided by this, we remain with only this, which is b into x plus 1. So that's what we have. But since this one and this one is common, what we can do, this one can cause, or what we can do, multiply by the LCM, which is x plus 1 times x minus 2. So we shall find this one will go away, so we shall remain with x minus 1 is equivalent to a into x minus 2 plus b into x plus 1. So that's what we shall have. So now we have, what we do next is now to choose which number can either make this one become 0 or make this one become 0. Which number? So you see, like for this case, when I put here a 2 we subtract with a 2, we get a 0. So we shall remain with only b. So for this case, I say when x equals a 2. So we put a 2 in every where there's x in this part, in this set, in this step. So when we put a 2 here, it will be 2 minus 1 is equivalent to, then we put here 2, which will give us a 0. So we shall remain with this one, which is a b into 2 plus 1. So this one and this one will give us 1 is the equivalent to this one, which is 3b. So for that case, our b